So moving on to the next lesson, looking at introduction to cable sizing. And I was saying that knowing the right cable to use for each system is as important as knowing the right inverter or the right battery to use. Now, when sizing our inverter cable, we need to determine the maximum current. And how we can simply do that, the formula is power divided by voltage. So the formula for determine the maximum current is to divide power by voltage. For example, if we have a 5 kVA inverter, we have to convert that 5 kVA into VA, that is 5,000 watts. Each inverter gives us an output of 230 volts, and the calculation is 5,000 divided by 230. That will give us 21.7 amps. So we need a cable that can safely carry more than 22 amps. That will determine our inverter cable. Let's look at more examples and take example, we have a 3.5 kVA inverter. Converting that to VA, that will be 3,500. And we know the output of our inverter will be 230 volts. So if you divide 3,500 by 230, that will give us 15.2. So we need an inverter, we need a cable that can safely carry more than 15.2 amps. So using this formula, you can determine any size of cable for any inverter. The key is to just know the inverter wattage and convert it into VA, then divide it by the output. So if we decide to use a bigger wattage, maybe we decide to use a 10 kVA inverter. For a 10 kVA inverter, we have 10,000 divided by 230. So that will give us 43.4. So we need a cable that can safely carry 43.4 amps. So that's about cable sizing and sizing our inverter cable. So when it comes to sizing panel, it's way different from when it comes to sizing inverter. To size our solar panel, each panel has to be connected in parallels. That is when we can get the maximum current of each panel. So supposing we have 3 panels connected in parallels, and if you remember, our parallel connection tells us that the current increases while the voltage remains the same. So this will help us in sizing our cable. To get the maximum current of 3 panels connected in parallel, we need to know the maximum power current or the short circuit current. To simply get this, you need to just look at your solar panel back like this. This is the solar panel, this is the label of the solar panel. So if you look out here, you can see the rated power in watts, 460 watts. We have the open circuit voltage, this is 69 volts. This increases when it's connected in series. So we have the short circuit current ISC. This is what we're working with, 8.62. The same thing with this one here. We have our short circuit current 10.4. So for our example here, we have 3 panels of 600 watts connected in parallel, and each has a ISC of 16 amps. So that gives us 48 amps for the 3 panels. Now we need to include what is called a safety factor. And you might be wondering, why are we using safety factor when we didn't use that for inverter? The reason is because solar panel generates energy from the sun, and the sun is not usually stable. The sun can be high today and the sun can be low next period. So we need to include safety factor to help prevent our battery, our cable from getting burnt or getting damaged. So applying safety factor here will be equal to 60 amps. So we need a cable that can carry at least 60 amps. So for this example that we have 8.6 amps here, 8.6 amps. If we have that connected in parallel, that's 8.6 times 3, that will give us 25. So if you're adding safety factor times 1.25, that will give us 32 amps. So we need a panel cable that can carry at least 33 amps. So that is what it is when you're sizing your solar panel cable. So moving on to battery cable. How do we size our battery cable? To size the cable for our battery, we need to determine the maximum current. And to do this, we need to figure out the formula for it. The formula is current is equals to power divided by voltage. Now, for example, we have an inverter of 5 kVA and the battery volts of 48 volts. So the 5 kVA current is equals to 5,000 watts divided by 48 volts. That will give us 104 amps. Now you notice how the current is much higher on the battery side because the voltage is lower. This is why battery cables are much thicker. So you can play around with this and we can use different examples to determine this. Let's say our inverter is still 5 kVA, but our battery voltage is 24 volts. So if we do 5,000 divided by 24, that will give us 208. So you can see that the voltage increases, the amps increases. So you can use this to size any single battery cable that you decide to size. And if you're going to use a much higher inverter, maybe a 10,000 watts, that's a 10 kVA, still 48 volts, that will give us 208. So sizing our battery cable or knowing the right battery cable to use is very, very important. And on the next slide, I'll be showing you guys the tabular form that you can pick, because knowing just 104 amps doesn't tell us what cable size to use. So the next slide will be able to solve that. So moving on to the next lesson, we'll be looking at the same table form that I use when sizing my cables. And you can use this to size your inverter cable. You can use this to size your solar panel cable. You can use this to size your battery cable. So for the examples that we've given so far, you can go back to it and you can come back here and use the tabular form to decide, okay, which battery suits that one. If your maximum current fall between 10 to 15 amps, you know that definitely I'm using 2.5 mm cable. If your maximum current fall between 15 to 20 amps, then you know I'm using approximately 4 mm cable. If it falls between 20 amps to 30 amps, then you can use 6 mm cable. If it falls between 20 to 50 amps, you can use 10 mm cable. There are some 10 mm cable that you can even use when it falls within 60 amps, right? There are some 10 mm cables that you can use if you can still use 10 mm cable if your maximum current fall within 60 amps as well too. So from 70 amps to 80 amps, you can now start using 16 mm. Then from 80 amps to 100 amps, you can use 25 mm, 35 mm, and the likes like that. So this is the exact same timetable that I use, or tabular form that I use, and you can always have this to come back and cross-check whenever you're sizing your inverter cable, or whenever you're sizing your solar panel cable, or whenever you're sizing your battery cable. So this will be like a guiding system for you that you can always reverse.